So continue on with example 2. So now I'm going to do my partial fraction decomposition to split up this larger fraction. So x minus 1 over 3x plus 1 times x minus 3 is equal to, again, both factors are linear, so I'm going to have an a on the top of the first fraction, and then I'm going to have a b on the top of the second fraction. And again, if I multiply everything by the LCD, I have x minus 1 is equal to a times x minus 3 plus b times 3x plus 1. So now to solve for a and b, I'm going to start looking at my first factor. The 0 that comes from x minus 3 is going to be x equals 3. So I'm going to let x be equal to 3. So I plug in 3, you've got to plug it into both sides. So 3 minus 1 is a 2, is equal to 3 minus 3 goes to 0. 3 times 3 is 9, 9 plus 1 is 10, so that's going to be 10b. So b is going to be equal to 1/5. So now looking at this other factor, that's going to be, I'm going to let x be equal to negative 1/3. So negative 1/3 minus 1 is going to give me a negative 4/3, is equal to negative 1/3 minus 3/3 is going to give me a negative 10/3 times a. Multiply both sides by negative 3/10. So that's going to give me a positive 2/5 for a. So now what I can do is I can plug 2/5 in for a, and I can plug 1/5 in for b. So now I can rewrite this larger fraction in the integral into these two separate fractions. Again, the 5 is going to stay on the outside of my integral. So again, a, remember, was 2/5 over the denominator of 3x plus 1. And again, I'm just going to go ahead and split this up into my two separate integrals. b, remember, I found to be 1/5. So I have 1/5 over x minus 3 dx. So now what I can do is, looking up here, I can pull out my constant, so I can pull out 2/5. So 5 times 2/5 is going to give me a 2 times 1 over 3x plus 1. I can pull out my 1/5. 5 times 1/5 is just 1, so I have plus 1 over x minus 3 dx. Now when I go to integrate 1 over 3x plus 1, be careful, you have to do a u sub here. U is equal to 3x plus 1. My du is equal to 3 dx. So I have to divide a 3 out of this integral. So the constant now is going to be 2 times 1/3, which is 2/3, times the integral of 1 over u, du, plus your integral of 1 over x minus 3 dx. So now I'm ready to integrate. So I go, the integral of 1 over u is going to be the natural log of the absolute value of u, so 2/3 times the natural log, again, if I plug in my 3x plus 1 for u, plus, when I integrate 1 over x minus 3, that's going to be the natural log of the absolute value of x minus 3 plus c. Again, remember, your answers may be written in different forms because they may use properties of logarithms. Now, the thing you have to be careful of is when you have an improper rational function in your integral. Again, an improper rational expression is when the degree of the numerator is greater than the degree of the denominator. If you've got an integral where this is the case, you have to make it proper. You make it proper by using long division. So you want to make this a proper fraction by doing your division. So again, when you do your long division, x to the third minus 4x divides into the numerator. So I'm just going to write this as my x to the fifth. I always include my placeholders. There's my 0x to the fourth minus 4x to the third plus 0x squared plus 0x plus 1. Now remember, the way long division works is you're going to take the first term and divide it into the first term underneath of your division sign. So when I take x to the third and divide it into an x to the fifth, that's going to leave me with an x squared. Then I'm going to multiply. X squared times x to the third is an x to the fifth. X squared times negative 4x is a negative 4x to the third. Remember, after you multiply, you're going to subtract. So x to the fifth minus x to the fifth is 0. That's 0. Negative 4x to the third minus a negative, that's going to go to 0. I have a 0x squared, 0x squared. The only thing left to bring down is my 1. I cannot take x to the third and divide it evenly into 1. So this is my remainder. So now, the way you write your answer, remember, is you take this x squared, you take the remainder of 1, and you place it over the divisor. So now this fraction that you're left with, when you take the remainder and place it over the divisor, you're going to now have to do your partial fraction decomposition on this part. So 1, and again I'm going to go ahead and factor the denominator. I can pull out an x. That's going to leave me with an x squared minus 4, which factors into x plus 2 times x minus 2. So you have to do your partial fraction decomposition on the fraction where you have the remainder. So in this case, you're going to have 3 separate fractions added together. So I have an A, B, and a C. So 1 is going to be equal to A times x plus 2 times x minus 2, and I multiply everything by the LCD, plus B times x, x minus 2, plus CX times x plus 2. So I'm going to start with letting x be equal to 0. So if I plug in 0 for x, I end up with 1 is equal to A times 0 plus 2 is 2 times negative 2, which is a negative 4A. B times 0, that goes to 0. C times 0, that goes to 0. So A is going to be equal to negative 1/4. So now to find my next one, I'm going to let x be equal to 2. So 1 is going to be equal to, this 2 minus 2 goes to 0. This 2 minus 2 goes to 0. So what I'm going to be left with is I'm left with c times 2, and 2 plus 2 is 4. So 4 times 2 is 8, so I'm left with an 8c. So c is equal to 1/8. And now I'm going to let x be equal to negative 2. So 1 is going to be equal to, again, when I plug negative 2 in here, that goes to 0. This goes to 0. So then I have negative 2b times negative 4. Negative 2 minus 2 is a negative 4. Negative 4 times negative 2 is an 8b. So b is also going to be equal to an 8. So now I know my a is negative 1/4. My b is 1/8. My c is 1/8. So now I can rewrite this fraction in my integral into these 3 smaller fractions. So again, my integral is going to be x squared plus, I've got my a, which was negative 1/4, all over x, plus b, which was 1/8, over x plus 2, plus c, which is 1/8, over x minus 2 dx. So using your properties of integration, make sure you have to be careful with your constants. You do want to split this. I know when I integrate, so again, I'll have the integral of x squared dx. I can pull out this 1/4 times your integral of 1 over x dx. Pull out your 1/8, and then pull out this 1/8. Now you can integrate each of these separately. So again, when I integrate x squared, that's going to be my, I'm just going to draw it down here, x to the third over 3. Minus 1/4, when I integrate 1 over x, that's just the natural log of the absolute value of x. Plus, when I integrate 1 over x plus 2, that's going to be 1/8 times the natural log of the absolute value of x plus 2, plus 1/8 times the natural log of x minus 2 plus c. Now, remember, you don't always have to be on the lookout and using partial fraction decomposition. Remember, the techniques that we have for integration, you have the u sub. Always check for that u sub first. Again, you use the partial fraction decomposition if you can factor the denominator. But remember, you also have completing the square. So if you look at this example 4, 3 over x squared minus 4x plus 8, you cannot factor this denominator. A u sub is not going to work. So that's where we're going to have to try setting this up for completing the square. So the constant I can pull out is a 3 times your integral of 1 over. Remember the way you complete the square, we're going to take negative 4, divide it by 2, which is negative 2, and square it. So I can write this as x squared minus 4x. Again, the negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm going to add a 4 here. But to keep this denominator in balance, I'm going to have to subtract the 4. So I should be able to factor now this perfect square trinomial into a binomial to the second power. And then 8 minus 4 is a 4. So we're setting this up to be one of our inverse trig. So remember, in order, this looks like an inverse tangent. This 4, we need to make it a 1. So I'm going to factor a 4 out of this whole entire denominator. Here's my 4. So now I can pull out a 1/4 out of this integral. So I have 3/4 times your integral of 1 over. We want to write this as a base to the second power, so I'm going to write this as x minus 2 over 2 squared plus 1. So now looking inside here, you have to do a u sub. So u is equal to x minus 2 over 2. My du is going to be a 1/2 dx. So I have to divide a 1/2 out of this integral or multiply by 2. So 3/4 times 2 is going to give me a 3/2. That's my constant. Times your integral of 1 over u squared plus 1 du. Now I can finish my integration. So 3/2. This is my inverse tangent. Take out the u and replace it with the x minus 2 over 2 plus c. So if you can't factor the denominator and a u sub doesn't work, that's when you're going to be looking at your completing the square. So if you take a look at letter B on page 18, again, notice you cannot factor this denominator. So you do have that x squared plus 2x. A u sub is not going to work. So again, this is one where we're going to do the completing the square. So again, there's no constant to pull out, so I have 1 over x squared plus 2x. Again, I have to take 2 divided by 2, which is 1, and 1 squared is 1. So I'm going to add 1 to make that perfect square trinomial. But to keep this denominator equivalent, I have to subtract 1. So I can write this now as a binomial to the second power as x plus 1 to the second plus 9. Again, I need to have a 1. So I have to factor a 9 out of the denominator. So again, a 1/9 can be pulled out of this integral. So I have 1/9 times 1 over, and I can write this base to the second power as x plus 1 over 3 squared plus 1 dx. So now I'm setting this up as my inverse tangent, so I have to do a u sub. So u is equal to x plus 1 over 3. My du is going to be a 1/3 dx. So I'm going to have to divide a 1/3 out or multiply by a 3. So I multiply 1/9 by 3, that's going to give me a 1/3. So I have 1/3 times your integral of 1 over u squared plus 1 du. So this is now set up for my inverse tangent. So I have 1/3 times your inverse tangent of x plus 1 over 3 plus c. So my answer is going to be B. So don't immediately jump to partial fraction decomposition, or don't immediately jump to your completing the square. Always check for a u sub, especially if you notice you have an x squared and then an x. Again, if you see that you have a degree less, if the denominator is one more degree than the numerator, that's where a u sub may be on the lookout. So if I'm going to let u be equal to my denominator of 3x squared plus 2x, my du is going to be equal to 6x plus 2, which it doesn't look like I already have in the numerator. However, if this happens, we notice that the numerator, if I multiply my numerator by 2, that would give me my du. So factor your du, take out a 2. So just like I've been doing with my other constants, I have to divide a 2 out of this integral, because here is that 3x plus 1 dx, which I can substitute in with that du. So I can pull out this constant of 1/2. So I have 1/2 times your integral of 1 over u du. So when I integrate, this is going to be 1/2 times the natural log of the absolute value of 3x squared plus 2x plus c. Or minus 1, excuse me. I forgot to write that minus 1. So again, when you look here, notice I've got an x plus 1 in the numerator, x squared plus 2x plus 10. So since the denominator is 1 degree larger than the numerator, let me see for a u sub. So x squared plus 2x plus 10. My du is going to be at 2x plus 2. So notice again, doesn't exactly match what I have already in this numerator. But I can factor out that 2. So there's that x plus 1 dx that I need. So I have the constant that I'm going to have to divide out of this integral. So I have a 1/2 times the integral of 1 over u du. So when I integrate, I have 1/2 times the natural log of the absolute value of x squared plus 2x plus 10 plus c. And that's how you handle the integration by parts.